this is from review. My screen's frozen. Okay, so we are starting parent functions. We are going to be working with these parent functions for quite a while, pretty much the rest of the school year. So you do need to understand the parent functions. Okay, Price, are we awake? Good morning. I know. It's Thursday, which means tomorrow's Friday, which means it's almost the weekend. Yeah? No? Just me? Okay. So, our first parent function is a linear parent function. What's the equation? Yeah. What's another way to say that? This is the same thing as just saying y equals x, right? Isn't that the same thing? Okay. So we know our parent function is y equals x. What do you notice about the graph? It's linear. It's straight. Okay. It's also the simplest. So looking at the equation, this is the simplest linear equation possible. Y equals x. So we worked with y equals x a lot. Algebra 1. Yes? We did a lot of linear in Algebra 1. So this is our linear parent function. What do you think our domain is? So first off, we know that this is going to keep going, and this is going to keep going. So remember, domain is our width. Is this ever going to quit getting wider? No. So what's our domain? So all real numbers. There's more than one way to write it. So we can say all real numbers, or that's the same thing as saying it goes from negative infinity to positive infinity. Okay? Both of those are correct. What about the range? Is it ever going to quit getting taller? No, it's not going to quit getting taller. So what is our range? Yeah, same thing. What about our x-intercept? Yeah, it's right there at 0. What's that as a point? 0, 0. Because remember, your x-intercept is when y equals 0. But your y-intercept is when x equals 0. Is it the same point? Yeah. It's the same point for both. I will tell you, a lot of our parent functions have 0, 0 as our x-intercept and our y-intercept. Not all of them, but a lot of them. Okay? So what about our maximum? Does it have a maximum? Does it have a minimum? No. So you can write none, you can leave it blank, you can write NA, it doesn't matter, whatever you want to write to remember.
How does it have a maximum?
Because it keeps going forever. So it's going taller forever and it's going down forever. Like it's never going to stop. Therefore, it'll never have a maximum or a minimum. Okay? Now, if there was a story and this was like somebody pouring out their drink, obviously would there be a maximum or a minimum? Yeah, because you can't have below 0 ounces of fluid in your drink. Does that make sense? And you can't have more than, I don't know, however many comes in a soda, like what, 16 ounces in a bottle or whatever. Okay, so those, when there's a situation, then there could be these things, but when it's just an equation, there will never be a maximum or a minimum. Okay, when we're just looking at the function. Now, does this have an asymptote? Do y'all remember what an asymptote is?
No.
So an asymptote is when something approaches something but never touches it. So you remember those graphs that we kind of looked at yesterday that like look like this? And you know how it gets really close to the x-axis but it never touches it? Does this have an asymptote?
No.
No. Okay, so this is an asymptote. This would be your asymptote here where it gets really close but doesn't touch. So no, our linear parent function has no asymptotes. I always have to think really hard about how I spell that. It's a weird word. Okay. Do you remember, so this is interval notation, right? Interval notation. Do y'all remember set notation? Notation. So set notation is what we did in Algebra 1. Set notation is this. Well, really, never mind. It's all real numbers. Haha. All real numbers is how you would write it in set notation. Not all of them are that way. That's why I wanted to show you. But we're going to do both notations on all of them. So, since this is all real numbers, set notation would just be all real numbers. Okay. So let's look at the next one. Does anybody have any questions on this one? Okay, flip to your next one. Okay, what do you think? What is this one called? Look at the title. Absolute value. Do you know what an absolute value is? So when you say the absolute value of something, you're saying the positive of something. So like if I ask what's the absolute value of 4, it gets rid of the negative, or negative 4, and it's just 4. The absolute value of negative 12 is just 12. Now the absolute value of positive 12 is just positive 12 because there's no negative to get rid of. So absolute value, those lines like this, these two lines, all they do is get rid of a negative. Okay, they cancel a negative. So that's why instead of being linear and keeping going down into the negatives, it pops back up to the positives because all of these numbers are just becoming positive. Does that make sense? That's why it makes a perfect V. Okay, because you can't have a negative x. Okay, so remember this is the same thing as saying y equals absolute value of x. Those are not ones, they're like lines. Okay? So, headphones should be up. Headphones should be up. Okay? What's our domain? Is it ever going to quit getting wider?
No.
No, technically it's going to go that way forever and that way forever. So it's going to keep getting wider.
It's going to keep expanding.
So what is our domain?
All real numbers.
All real numbers. How do I write it in interval notation? Negative infinity to infinity with parentheses. And then set notation is our all real numbers. Now, is my range all real numbers? No, why not? Because it doesn't go down forever. Does it go up forever? Yeah, it goes up forever, but does not go down forever. So what's its lowest point? 0. Okay? So my lowest point, am I going to use a bracket or a parentheses? Bracket, because it does actually touch 0, right? So 0, and then it goes all the way what? To infinity. And do I use a bracket or parentheses? Parentheses. Now this is where set notation kind of comes into play. This is just saying y is greater than or equal to 0. So those two ranges mean the same thing. Okay? Those two ranges do mean the same thing. So what's our, do we have a maximum? Oh, x-intercept first, haha. 0, 0. And what's my y-intercept? What about my maximum? Do I have a maximum? No. What about a minimum?
0.
It's 0, 0. So we're going to write it as a point. If you just write 0, that's fine. Okay, so I'm going to write them as a point today. Does this graph have an asymptote? No. No asymptote. Asymptote.
How would it be an asymptote?
Huh?
How would it be like an asymptote?
So we'll get to a couple that have asymptotes, and then you'll kind of understand what I mean. Okay. Any questions here? Okay, so let's move on. What's next? What's this one? Quadratic. Have y'all dealt with quadratic before?
Yeah.
Yeah, we did quadratic in Algebra 1 as well, right, Monica? Sleepyhead. Okay, so we have our arrows. What's our domain? Price, are you awake? It's all real numbers because it's never going to quit getting wider. So this is negative infinity to infinity for interval notation. or all real numbers for set notation. Now, what about the range? Yeah, it's 0 to infinity with a bracket or a parentheses? A bracket, then a parentheses, yes. Okay, so that's just saying y is greater than or equal to 0, because everything from here and up is the range. Okay? What do you notice about that and from the last graph? Same. The absolute value in this one are the same, but do they look the same? What's the difference? Absolute value looks like a V and this looks like a U. Okay? Other than that, they're pretty similar. Okay? What's my x-intercept? 0, 0. What's my y-intercept? Does it have a maximum?
No.
Does it have a minimum?
Yes.
What is it?
0.
The point 0, 0. Does it have an asymptote? No. So what's the next one? So this is the square root parent function. I want you to realize something here, that it does stop right here. And the reason it stops is because you cannot take the square root of a negative. So it cannot have a negative x and it cannot have a negative y. Okay? So that is why it stops. Okay? So this is the same thing as saying y equals square root of x or y equals x. This is to the 1/2 power. Okay? Anytime you have an exponent of a half or a fraction, it's the same thing as taking a square root. Okay? Price, you awake? Okay. So, what's my domain? Is it all real numbers again? No, because it doesn't go for the left forever?
No.
No, it stops. It does go to the right forever. So, what is my domain? 0 to infinity. Okay, which is the same thing as just saying x is greater than or equal to 0. Okay, what about my range?
0, 0.
Not 0, 0. It starts at 0, and does it go up forever? Yes. So it goes from 0 to infinity. So my domain and range look exactly the same. So what's my x-intercept? What's my y-intercept? 0, 0. They're the same. What's my maximum? Do I have a maximum? No. Do I have a minimum? What point is it? 0, 0. Does it have? Because they're all the parent functions. That's what I'm saying. They're all the parent functions. Parent functions are very similar because a lot of them start at the middle. That's why we call them the parent function, because they're all the simplest. There's no changes, there's no shifts, none of that. So a lot of them are very, very similar. And I told you a lot of them are going to start at 0, 0 because they're the simplest and they're like the perfect of that graph. Does that make sense? Okay. So, asymptote, yes or no? No. Okay, what's next? Cubic. So we've talked about cubic. So this is the same thing as saying y equals x cubed, or x to the third power, whatever you want to say. Okay, what's my domain? Is this going to get wider forever? Yeah. Okay, there's no asymptote here. Okay, so we know my domain is all real numbers, or negative infinity to infinity. What about my range? Same thing. X-intercept to y-intercept?
0, 0.
They're the same, so they're both 0, 0. Maximum or minimum? No. Okay. What do you notice from the cube to the cube root, or cubic to the cube root? What are they? What's the difference? What's the same?
The squiggle is more.
Yeah, they've got kind of the same shape, but is it the same direction? No, it's just kind of like turned sideways, right? Okay, so this is kind of the opposite. Instead of cubing it, we're doing cube root. So instead of square root, it's to the third, or it's y equals x to the 1/3 power. Okay? Domain, is this ever going to quit getting wider?
No.
Is it ever going to quit going up and down?
No.
No, so they're going to be the same because there's no asymptote. I promise some of these have asymptotes. We'll get there. Okay, so my domain is from negative infinity to infinity. There's 9. I don't know. 1, 2, 3, 4, 5. This is 6. We'll get there. Okay, what's my x-intercept? What's my y-intercept? 0, 0. Maximum, minimum? No. Okay. So this is the exponential parent function. We have talked about exponential. I know today is a lot of me talking. I know it kind of sucks, but we have to get all these in so we can start comparing them, okay? So, exponential parent function is something we have covered, okay? So the parent function, I know this is like the only parent function that has a number, right? Have we seen any of our parent functions have numbers in them other than like little cube roots and stuff?
No.
They've all just been an x, but this is 2 to the x power, okay? Why do you think it has a number and not 1? 1 times 1 is what? 1 times 1 times 1 times 1 is what? 1. That's why they don't, like, that's why it's not the number 1, because you can't have a 1 to the x power. It's just going to be 1. So it would just be a straight line at 1. Does that make sense? That's why that can't be the parent function. Okay, so domain. Does it get wider forever? Okay, yes. So it's going to be negative infinity to infinity. All real numbers. But does the range get wider forever? No. Does this have an asymptote? Yes. What's my asymptote?
0.
So it's a horizontal asymptote at y equals 0. I should have wrote horizontal. At y equals 0. Will it ever touch 0? No. Will it get super, super close?
Yes.
I'm talking like 0.00000000001 and closer. Okay, like ridiculous numbers that you would never write out. Okay. So knowing that, what do you think my range is?
How is it an asymptote again?
So because it gets super close to 0, but it never actually is going to touch it. So that's why it's an asymptote. Asymptote just means it gets super close but never touches. So it approaches but never meets. Well, it's going to be 0 to positive infinity because it doesn't go down to negative infinity. So we start at 0 and go to infinity. But do I use a bracket or parentheses? Parentheses. Why parentheses this time? Because it doesn't actually touch it. There's no point there. Okay, so it's 0, infinity. which is the same thing as saying y is greater than 0. What's the difference on my y is greater than 0? What did I not do, Moses? What is it missing, Christ? Does it have the equal to? No, that's what's different, okay? That's how we know it doesn't actually touch, because it doesn't have the equal to this time, okay? X-intercept, Y-intercept, are they different? Yeah, what's my X-intercept? Does it ever touch the X-axis? No, so there is none. There's not one.
Well, how does it not touch it?
Huh?
How does it not touch it?
It doesn't ever touch, it gets super, super close. So like I said, like 0.00001, 0.0000001, so on and so forth. It gets super close. Like you could type it in your calculator. Watch.
It look like it touches.
It doesn't. It just gets so close that it looks like it does. So, but if you'll always notice that it'll never go under the line, and that's how we know there's no asymptote. Because it never goes underneath that x-axis. Or, yeah. So if you come here and you graph it to the x power, and you go to our table, we could go forever up. Do you see how it never goes into a negative number? Now, I don't know, do y'all know what these e's mean? That just means how many zeros are in front of it. Because it's such a big decimal that if they put it in here, all you would see is 0.00. Okay? So that means it's such a big, but if you notice, they never become negative. I can keep scrolling forever and ever and ever, and they will never, ever become negative. Okay? So that's how we know it has an asymptote, because it will never go to 0 or negative. Like it'll never have a number, comma 0. And it'll never have a negative in its y. Okay? So, our y-intercept is what? 0, 1. Be careful, because remember your y-intercept is where x equals 0. Does it have a maximum? Does it have a minimum? So it doesn't have an actual minimum point, but does it ever reach 0? No. So it doesn't have an actual point, so we're going to put an A. But it'll never go below 0. So that's just kind of where the asymptote comes in play. Okay? So next one. This is a logarithmic parent function. Okay? Domain. Do you think this one has an asymptote? Well, does it ever go to the other side of this axis?
Oh, yeah, it does.
It does. It has a vertical asymptote. Okay? Vertical asymptote. And it's going to be where x equals 0, because it's right here. And that's where x equals 0, because it doesn't go side to side. Okay? So what's my domain here? Does it ever go past 0?
No.
No, so it's 0 to infinity, but with parentheses, because there is no point at 0. So this is just x is greater than 0. What about my range? Does it go up and down forever? Yeah. So my range is all real numbers. Negative infinity to infinity are all real numbers. X-intercept? 1, 0. Y-intercept? Will it ever touch the y-axis? Monica? Does it ever touch the y-axis? No. Okay. Does it have a maximum? Does it have a minimum?
Yeah.
No. Okay, last one, really fast. Right? This is the last one? No. Yes. Yes. Woohoo! Okay, I just want to get through it today so tomorrow can just be like, nah, no, it's all period. Okay? So this is the rational parent function. Again, it's the same thing as y equals 1 over x. Okay? Does this have asymptotes? It has 2. Okay? So I want you to realize, doesn't it get really close to this axis but never touch? It also gets really close to this axis and never touches. So we have 2 asymptotes. 2 asymptotes. One at x equals 0 and one at y equals 0. So one vertical and one horizontal. Okay? So what's my domain? Do you think we're going to have two domains? Yeah, because I want you to realize something. I want you to realize that there's kind of two different lines. Do you think, does anybody know why? It's because you can't have a zero on the bottom of a fraction. You cannot have a zero on the bottom of a fraction. So there will never be a number at 0, never be a number at 0. Okay? Does that make sense? Okay, so that's why it looks like that. So what do you think your domain is?
For both of them, infinity, negative infinity.
So it'll be 0. We'll start with the smallest. So negative infinity to 0. And 0 to positive infinity. But since I have parentheses, that's telling me that it never actually touches 0. If I had brackets, it would be pointless to have 2. So same concept for your range. Negative infinity to 0, 0 to infinity. Now, you could say for the set notation, you could say all real numbers when y doesn't equal 0. Or x, sorry, that's domain. And then all real numbers when x doesn't equal 0. Why? Dang it. Why did I do that backwards? Sorry. Okay, x-intercept, does it have one? Does it have a y-intercept? Does it have a minimum? Does it have a maximum? So once you finish your NAs or leaving it empty, you can pack up. Okay? What? Your point's wrong on the quiz?